Okay, here we go, everybody. Moving on to day 3 of the area unit. So far, we've covered areas of a triangle and parallelogram, and then we did a day on area of a trapezoid, rhombus, and kite. Now we turn our attention back to our previous unit, which is the circle. Area of a circle, I've written this on day 1, is pi r squared. All right, radius squared times pi. All right, so here we go. Let's find the radius of a circle with an area of 95. Oh, great. I'm starting you off right with an honors level question. I'm telling you the area. What is the radius length? All right, so area, pi r squared. The area is 95, so I plug in 95 for the area, and I'm solving for r. Okay, solving for r. So again, if I want r by itself, I'm going to divide by pi. Divide by pi. Remember, we do not, and this is, just not this year, it is any year. All right, next year in Algebra 2, we do not round anything to the very end. Okay, so if you guys decide on your calculator right now to do 95 divided by pi, you keep that full decimal or write it out. All right, I'm just going to keep it as r squared equals 95 divided by pi instead of writing out that full decimal. And then how do I get r by itself? I'm going to take the square root of all of it. Now I'll plug that into my calculator, the square root of 95 over pi, and rounding to the nearest hundredth, I should end up with 5 point, let's see, that's going to round that. So I'm going to 5.50. Okay, check it in your calculator. All right, get up a calculator on your Chromebook right now. All right, 5.50, oh, one job, centimeters, right? Okay, so a quick area of a circle problem right there, solving for the radius. All right, now what we're going to pay attention to today is a sector. All right, a sector. And as you can see here in my diagram, a sector is a region bounded by two radii. So here are my two radii and their arc. Okay, think of it as a piece of pizza. It's a slice of pie, right? That's the part of the circle, sector. All right, sector of the circle. So we have an area formula for it. A lot of formulas this unit, right? Just going to add in another one right now, the area of a sector. So how do I find that area? Well, it depends, because as you remember from the circle unit, this angle right here, take a look, angle AOB, that could be in degrees, or we learned a new measurement last unit, which is radians. Okay, so there's going to be two different formulas. If the angle's in degrees, I want to use the measure of the arc over 360 times the area of the circle, pi r squared. Okay, and again, the measure of the arc should be in degrees. And now what if that central angle right here is in radians? All right, I have another formula. If it's in radians, it's going to be 1/2 radius squared times theta. Now remember, theta is the central angle in radians. Okay, central angle in radians. Now, quick review here. You can remember both formulas if you want, or remember one, but again, have the ability to convert back and forth. So quickly, if you remember, if I had 30 degrees and I wanted to turn that into radians, because you wanted to use the 1/2 r squared formula, you would have to multiply it by pi over 180. Okay, reduce that fraction and it would be pi over 6. Okay, if you wanted to go backwards, say you had 5 pi over 6 radians and you wanted to turn it into degrees, you would multiply it by 180 over pi, cancel out the pi's, and that would end up with 150 degrees. Okay, so again, memorize both or just choose one, but make sure you're able to convert if needed. All right, because again, this formula, the 1/2 r squared theta, can only be used if you have radians as your angle, and measure of the arc over 360 times pi r squared can only be used if you have degrees. for the purpose of these notes, I'm going to use whatever's given to me. So if I'm given radians, I'm going to use the radian formula. If I'm given degrees, I'm going to use the degree formula. Okay, so just heads up on that as we continue on through these notes. All right, so what's the area of a sector of a circle with a radius of 8 inches formed by a central angle of 60? All right, we'll take a look. 60 is in degrees. So I'm going to use my measure of arc over 360 times pi r squared. If you want to use the radian formula, you got to convert it into radians. So the measure of the arc is equal to the central angle, which is 60 over 360 times pi. Radius is 8 squared. Okay, so that's how we're going to do that one. All right, so if you go to your calculator right now, and you notice our answers, guys, all our answers have pi in it. So you want to make sure you leave the pi in your answer. So when I go to my calculator, I'm going to do, all right, fraction template, 60 over 360 times 64. And that'll give me 32 over 3. Leave the pi in your answer because all the choices are left in terms of pi. And it's going to be choice number 3. Okay? All right, let's go over to the right for example number 3. All right, we got, the measure of the arc BC is 108. And we're looking for, some of the students wrote formulas to find the area of sector COB. So sector COB again is going to be this entire sector right here. Okay, that entire slice of pie or piece of pizza right there. Which students wrote the correct formulas? All right, let's go through each student now and see if they did it correctly. So Amy, and it looks like they're using the degree formula because you're given 108 degrees. So Amy's saying, all right, it's 3/10 times BC squared. Well, first of all, where'd the 3/10 come from? What she did was she used her formula 180 over 360. And if you reduce that 180 over or 108 over 360, you'll see it reduces down to 310. So she's all right there. That's fine. Here's the part I don't like. BC squared. Guys, take a look at the diagram. What's BC? BC is a chord. It should be a radius squared, right? Pi r squared. That's a chord. Amy, you've been eliminated. One job. Okay, let's see how the old Bether did here. 108 over 360, that's fine. Times pi. OC is a radius. So she did square the radius. So Beth, welcome to honors. You're good. All right, what about big C dog here, Carl? 3/10, we know that's fine. That's just 108 over 360 reduced times pi. Now, did he square the radius? Well, what's AB? AB is the diameter, and he took half of that, so you get the radius squared. Nice job, big C dog. You can join honors. Dex. What do we think? Short for Dexter? Who knows? Okay. So, one second, guys. Okay, back to business here. Sorry, guys. We're checking Dex. So Dex says, all right, 108 over 360, that's fine, times pi. But now take a look. What's he end up squaring? He's squaring AB. I don't want the diameter. I know there's a half outside, but you're squaring the diameter first. No. We should be squaring the radius first. All right, so Dex, sorry, not honors level. It's going to be Beth and Carl as our winners here. All right. Moving on, diagram below of circle O, the area. Okay, so now they're giving me that the area of this shaded region is 12 pi. And the length of OA is 6 inches. Determine angle AOC. Okay, so now we're going to be solving for a different part of this sector. All right, so really we could choose either formula here, the radians or the angle. I'm going to choose the angle one here. So we know the area of the sector, I'm just going to write everything out, is equal to the measure of the arc over 360 times pi r squared. Okay, measure of the arc, measure of the sector is 12 pi. Plug it in. The measure of the arc, which is angle AOC, I don't know, so I'm going to plug an x there. Over 360 times pi radius of 6 squared. Okay, let's keep cleaning this up. 12 pi equals x over 360 times 36 pi. Okay, now we have a lot of options right now. All right, we do have a lot of options. How about we get rid of that 360 in the denominator? Okay, so I'll multiply both sides by 360. So they'll cancel out, and I'll be left with 360 times 12. Real quick check. 4,320 pi. And what am I left with on the other side? 36 pi times x. You guys have pi's on both sides, so eventually we know what's going to happen. They're going to cancel each other out. I got to divide both sides by 36. And I get 120. So x is equal to 120 degrees. Okay? Could you have also used area equals 1/2 r squared theta and did it that way? Sure, absolutely. You know, we could have said 12 pi, and I'm doing this because we're in honors, 1/2 r squared, whoops, 6 squared. We already know what that is. 6 squared times theta, which is the angle I'm trying to find. And then we go from there. Okay, your answer would have I'm going to keep going. 12 pi equals 1/2 of 36, which is 18 times theta. Divide both sides by 18. Theta would equal to reduce 12 over 18, you get 2 pi over 3. And that's in radians, which is equal to 120 degrees in degrees. Look at that. Okay, so either way would have worked there because it doesn't specify what type of unit to leave it in. Whew. All right, big timers coming up here. Number 5 to the nearest, find the area of the patio below. All right, well, what's the patio made up of? Here's the first time we're going to experience this. The patio is a trapezoid plus the half circle. Okay, so if I was doing my formulas out right now, that would be 1/2 the height, base 1 plus base 2, plus 1/2 the circle, which is pi r squared. All right, I'm going to leave this to you guys right now. All right, I'm going to pause the video. You do the same. See if you can come up with the correct answer right now. Get to it. Okay, everyone, we should end up with 72.5 square feet. All right, the trapezoid, everything was given to you. The 2 bases are given and the height's given. And then for the circle, you just had to cut 10, which was the diameter, in half and get 5 squared. All right, so that's what we ended up with, 72.5 square feet. All right, moving along. Okay, now we got a rhombus and 3 half circles, huh? All right, so find the area of the entire figure. So it's going to be equal to the rhombus plus 1.5 circles, right? So the area, if I break out the formulas, 1/2 d1 d2 plus 1/2 times area of a circle, pi r squared. All right, so here we go. I'll do this full one here with you. The diagonals of a rhombus. All right, they already gave us the diagonals. That's awesome. So 24 and 10 plus 1/2 pi. Now we got to find the radius. And if I take one of these half circles right here, that's your diameter, right? That is your diameter. So if I knew that length, I would cut it in half and put in the radius. But do I know what that's going to be? Not off the top of my head. All right, I'm going to have to do some algebra with that. So let's go back to the fact that the diagonals are 24 and 10. They bisect each other. So now I'm talking 12 and 12, 5 and 5. And as we also know from day 2, diagonals are perpendicular. So to find that diameter, I could just do 5 squared plus 12 squared equals c squared. Pythagorean theorem. And then I'll end up with 13 for the full diameter, which would mean the radius is half of that, or 6.5. Okay. Next thing here. This is why I didn't leave it to you on your own. It says, hey, leave your answer in terms of pi. You need a pi in your final answer. So I can't just, click, click, click on the calculator and round. It's got to have a pi in the answer. So how far can I go here? Well, I can definitely do 1/2 times 24 times 10. That'll give me 120. I can certainly do 6.5 squared, then times that by 1.5, right? 6.5 squared, and then multiply that by 1.5. So that'll give me 63.375 pi. All right, I'm good there. Now the question is, can you combine those two? Or is this in terms of pi? All right, can I combine the 120 and the 63.375? No, you cannot. You cannot, that's like having an X there instead of a pi. You can't combine them. So this right here is in terms of pi. We're done. Okay. And then last one here. We got to find the area of the shaded region. Let's just write down what I'm given. AB, that diameter is 26. CB is 10. Find to the nearest the area of the shaded region. All right, well, let's make up a plan and I'm going to let you go on your own. So the area of the shaded region. I can take the area of the half circle, and instead of adding like I've been doing the last two problems, I can subtract the area of, what's that figure that's unshaded? The triangle. So that's my plan right now. I'm going to do 1/2, because it's a half a circle, pi r squared minus 1/2, because it's a triangle, base times height. And remember, since this is a right triangle, the base and the height are the legs, AC and CB. Okay, so that'll be AC, that'll be CB. So go ahead, pause the video, see if you can find those values, and then round it to the nearest square unit. Get after it. Write it out. Don't just write down my work. Okay, so we should end up with 145, rounding to the nearest square unit. For the circle, the radius had to be 13. That's half of 26. All right, and then I did a little Pythagorean theorem over here. All right, to find the other leg, I knew one leg was 10, CB. The other leg, I did it using Pythagorean theorem and got 24. Subtracted the two and got 145. Okay, the homework looks like it's on pages 11 and 12. Some working with area of a sector, and then shaded regions here. Okay, number 7 and 8. Do not give up. All right, do not give up. I know it's tough. Tough right now to find the motivation, but you guys are honors level and we don't give up here. Okay, we do not give up. All right, good luck, guys.